Hey guys, what's up? I hope your Tuesday is going great and I hope you're ready to do some more pre-algebra math together. Now remember, we're working on radicals and we have done some work with some square roots. And if you remember from yesterday, a square root is a number that has a product that when multiplied by itself is itself, meaning the original number that was under the square root symbol. And so we're going to build on that today, and I'm going to get out of the way so that you'll be able to see the board. As we are building on it today, we're going to be working on what are called radical equations. I first want to define, before we get to the numbers themselves, what exactly are radical equations. A radical equation contains a variable, which is, of course is a letter, like x, and it has to be, this is important on what you're looking at as the right side of the board here, it has to be in what's called a radicand. Now, we've worked with these, we did that yesterday, we just haven't really defined it as of yet. But a radicand is simply what is underneath the square root symbol. And so a radicand, again, is what's under the square root symbol. And so the variable needs to be found underneath that for it to qualify as a radical equation. Now you could have a square root in an equation, but the variable not be underneath the square root or the radicand, and it would not qualify as a radical equation. Well, you can see in all of these that we're going to be solving today, they're just 5 problems, and in all those that we're going to be solving, there is a variable that's a part of that radicand or underneath the square root in each one of these equations. And so let's go through and let's solve each one. Just a quick reminder, I'm going to jot something on the board and then I'm going to erase it, okay, because it's not going to be a part, say, of number 4 problem where I write this. But in solving an algebra problem, when you're trying to isolate x all by itself, or y or a or b, we know by now the letter itself doesn't matter, it just represents some number. But when you're trying to solve for x, and again, this doesn't apply to number 4, I'm just giving an example, and you have something that's added to the x, how do you get rid of what's added to the x? You do the opposite operation, which is you subtract the same number, okay? Well, let's say that if you have a number being subtracted from x, how do you get rid of that or detach it from the x? Well, in that case, you would add it. You do whatever the opposite is. If you have a number, I'm going to write it as an x. That's not the x variable, but like times. I know normally we don't do that. We just put a dot. But if you have a number being multiplied to a value, say like y, and you're trying to isolate y all by itself, what do you do to get rid of that number that's attached to it? You would divide, which is the opposite. If you have a number that is dividing your variable and you want to get that variable all by itself, what do you do to do so? In that case, you're going to do the opposite of division, which is multiply. And so we're used to doing the opposite signs to get rid of something attached to x, right? Well, what do you think we're going to do today when we find a square root attached to, if you will, x? How are we going to get rid of that? Well, the only way you can do it is to square, let's say it's an x value, the only way you can do it is to square that x, because remember, squaring is the opposite or the inverse of what a square root does to a term. And so that's what we're going to be doing today. And by the way, this will come later, but if x were being squared, what's a way that we could get rid of that? Again, that's going to come in a later lesson, but we could put a square root for that x squared, which will bring it down to x. That's the opposite operation. So we've done the basics of this. You do a subtraction if it's being added. You do subtraction if it's being, you do addition if it's being subtracted. If it's being multiplied, you divide. If it's being divided, you multiply. Well, if the square root is being taken of it, to get rid of that, you're just going to square it. And so that's what we're going to do with each one of these. And let me get rid of that. Again, that doesn't apply to number 4 necessarily, or not right now. But we're going to apply this logic, this information, to number 1. Let's just do a really simple one. If I'm trying to solve for x, guys, and the square root of x equals 5, how do I get rid of that square root so as to isolate the x all by itself? I have to do the opposite of what a square root is, or what it does to a term. And the opposite of that is going to be squaring it. Does that make sense? If it were being added, you would subtract it. If it were being subtracted, you would add. If it's being multiplied, you divide. If it's being divided, you multiply. If the square root is being applied, you square it, which is the opposite, just like the opposite signs and all those other operations. But this is key, guys, and don't let me lose you on this. Whatever you do to one side, you always have to do to the other side. Now, the whole purpose of squaring the square roots of x is that drops the square root and just leaves x all by itself, which is what we wanted all along. The squaring gets rid of the square root, and that leaves x by itself, mission accomplished. But we have to apply the square that we did on this side to the right side of the equation. And what is 5 squared? 5 times 5, and remember, that is not 5 times 2, that's different. But 5 squared, or raised to the second power, means 5 times itself. And so 5 times 5 equals 25. We're done. We just solved that equation. The square root of x equals 5. X equals 25. Now, what we can do is we can go back, and we need to do this on square roots because sometimes we'll find that they actually don't work when you plug them back into the equation. So let's do that right now. Let's go back to our original equation and plug in for x what we found x to equal, which is 25. If I have the square root of x, which is what now? We just found it to be 25. So instead of the square root of x, I put in the value for x I discovered, 25. And so the square root of 25 equals 5. Question: what is the square root of 25? In other words, what number times itself gets you back to the original number that you had under that square root? 5 times 5 is 25. Therefore, the square root of 25 is 5, and you still have 5 on the other side of the equal sign. Look, 5 equals 5. Is that a true statement? Then yes, you did the problem correctly, and that is the appropriate answer. X equals 25. And we just checked it, and since we came up with a true statement, we do know that it works. Now, on number 2, let's try this one. What we have is the square root of x equals -8. I'm not trying to solve for the square root of x. I'm trying to solve for x and x alone. So guys, how do I get x all by itself on number 2? If the square root of x is being taken, I have to do the opposite of that. What's the opposite of the square root, or the inverse of that? The opposite of a square root is to square. And when I do that, it gets rid of the square root, which is the whole purpose of doing it, and gets x all by itself. But Ken, what I do to one side, what do I have to do on the other side? The very same thing Ken would tell us. Good job. That's that brilliant mind. That's that genius, right, Ken? Self-proclaimed. But at work, and he is very sharp. So we're going to square -8 just like we squared the square root of x. The reason for our doing that on the left side is that drops the square root, which is what we want so we can solve for x. But now we have to square -8 to come up with a value for x. So, what is -8? Remember, that is not times 2. Alright, that is not times 2. That is raised to the second power, or squared. That is -8 times itself. What is -8 times -8, or if it's easier, 2 negatives are going to make a positive. And so what is 8 times 8, if that makes it easier to calculate in your mind? We're good at our multiplication table when we want to be, and 8 times 8 is 64. And so x equals 64, and that's the solution. Maybe. Let's go back and check it and make sure it works as a solution, because there are some times that it doesn't, and then that's not the answer. And in fact, there's no real solution. Let's see if this might be one of those. Let's plug in the value that we found for x into our original problem. The square root of x, which we have now found to be what? X. X equals 64. So the square root of 64, instead of the square root of x, the value we found, equals, in our original problem, negative 8. Alright, well, let's do the math. Guys, what is the square root of 64, which means what is a product of 64 that when multiplied by itself gives me that number under the square root, which is 64? And the answer to that is 8. 8 times 8 gets me 64. Now, write what we have on the other side. 8 equals negative 8. Nikolai, is that a true statement? Does 8 equal negative 8? The answer is no. Therefore, since it does not equal it, there is no solution, which remember is like a 0 with a line through it. It's not a 0, but it's a 0 through a line through it, and you can circle that, and that means there is no solution or no real number that's going to work in that equation. Now here's the reason why. Let me teach you a shortcut. You can go through and check every one of these if you want, or when you get down to just the square root of x and equal something in an equation, if there's a negative number on the other side and all that's left is the square root of x on the left side, when that's the case and you have a negative number on the other side, it will always be no solution. And the reason for that, remember, is that if you have two positive numbers multiplied by each other, you only get a positive. But if you have two negative numbers multiplied by each other, you also are only going to get a positive, because two negatives make a positive. So the square root of x can never be or never equal a negative number. And so really, now that we know that trick, we could have just looked at the original equation. The square root of x equals a negative number, negative 8, and we could say, hang on just a second. I'm not going to waste my time and go through all this work, because that can never be the case. The square root of x can never equal a negative number. Okay, now that we know that little trick, maybe it'll save us some time as we move forward. Let's see. Let's do number 3 together. Now, when you have the square root of 3x and the square root stops there, and there's something detached from that, but at the same time it's kind of connected by an addition symbol and a number coming after, plus 2, equals 8, don't take care of the square root first. Order of operations would tell you, oh, take care of that first. But what we have here, guys, is a two-step equation. And remember, in a two-step equation, everything I know and you know is wrong. That's right. In a two-step equation, everything you know is wrong. So you reverse order of operations. And so just like what we've done with other problems, I'm going to take care of this plus 2 that is not under that square root sign, or not a part of that radicand. I'm going to take care of that plus 2 and move it to the other side away from the variable and that square root before I do anything else. And Kelsey, if I have plus 2, or I have 2 being added to that 3x, that's a square root also, how do I get rid of that plus 2? Well, the way I do that is to do the opposite of what's being done to it. I'm going to subtract 2 from both sides, which gets rid of my 2 over here, which is what I wanted. I'm left with the square root of 3x equals, what is 8 minus 2? 8 minus 2 is 6. Okay, so what I have is the square root of 3x equals 6. Now I have a one-step equation, and there's technically it's 2, but it looks more like what our one-step equations typically are. And how do I get rid of the square root of 3x? How do I get rid of the square root? I have to do the opposite operation. What's the opposite of taking the square root of something? It is squaring that very thing. And so I square the entire term, but remember, what I do to one side, guys, I have to do to the other side. And so I also need to square my 6. Now the whole purpose of squaring the square root of 3x is to get myself down to just 3x. And now I can operate from there. But I have equals, what is 6? Note, not 6 times 2, but what is 6 squared, or 6 times itself? 6 times 6 is 36. And so 6 squared is 36, and what I have left is 3x equals 36. Now, I need to solve not for 3x, but I need to solve for x. And so how do I detach, Joey, that 3 from that x? How are they connected at this point? They are connected by an invisible multiplication sign. And so I do the opposite of multiplication, which is division. I divide both sides by 3. And my whole purpose of doing that is to get rid of the 3 on the left side. And so all I have left is x equals, how many times does 3 go into 36? 3 goes into 3 one time, and 3 goes into 6 2 times. And so x equals 12. Now what I want to do is I want to plug this back into my original equation, the square root of 3x plus 2 equals 8, and make sure I have the correct answer. And so what I'm going to do is plug in the square root of 3 times x, which I found now to be what number? 12. So 3 times 12, okay, and all that's under the square root. Now this part, plus 2, is not. Alright? And then I'm going to have equals 8. Now, first thing I'm going to do is I'm going to reverse the way I think. It's basically a two-step equation. You could technically argue it's 3, but largely it's a two-step equation really here. And what I'm going to do is get rid of that plus 2, as I've already done before. Okay? If I want, I'm going to subtract 2. You want to do that. Okay? And so what I'm going to have is the square root of 3 times 12 equals, what's 8 minus 2? 6. Okay. Now I need to simplify on my left side. What is 3 times 12? 3 times 12 is 36. So I have the square root of 36 equals 6. Guys, what is the square root of 36? In other words, what product of 36, when multiplied by itself, gets you back to the original number that you had, which was 36? The answer to that is 6. 6 times 6 is 36. And so the square root of 36 is 6, and so I have 6 equals 6. Is that a true statement? Woo! Bingo! Then that means that I'm on the right track. I know that's not really easy, and we took a big step up right there. So let's do some practice with 2 more before we call this one a day. Okay? Number 4, I have the square root of 10 plus x, and that's all that's under the radicand, or the square root symbol, plus 6 equals 7. Guys, what's the first thing that I need to do in this, which is basically a two-step equation at this point, or it needs to be treated like it? The first thing I do, everything I know is wrong because of that, and so I need to do addition and subtraction first. I have a 6 being added to this square root of 10 plus x. And so the way I get rid of a plus 6 is to minus or subtract 6. And what I do to one side, I have to do to the other. I'm going to subtract 6 from both sides, which gets rid of it over here, and I still have the square root of 10 plus x equals, what is 7 minus 6? 7 minus 6 is 1. Alright, now I've done everything I can except deal with the square root, and so that's my next order of business. What do I do to get rid of a square root? In other words, what's the opposite of a square root? The opposite mathematical process is to square it. And so I'm going to square the square root of 10 plus x. But what I do to one side, I have to do to the other. So I have to square that 1 as well that's found on the opposite side. So when I square the square root of 10 plus x, all I have left is 10 plus x. The reason I did it was to get rid of that square root symbol because it doesn't help me a whole lot the way it is. But to do so, I have to square the other side also. What's 1 squared? Well, that's an easy one, huh? 1 squared is simply 1. Okay? Now, what do I do from this point? I have a positive 10 that's being added to that x. And so since that's a positive 10 that's sitting there being added to the x, how do I get rid of that, what is essentially a plus 10? I have to subtract 10 from both sides, which leaves me with x only on my left side, which is exactly what I want. And what is 1 minus 10? Well, the bigger number is the 10, and so it's going to end up being a negative in the end, and since I have a positive 1 and a negative 10, opposite signs, I'm going to subtract the smaller from the larger. 10 minus 1 is 9. 10 minus 1 is 9, but the larger number is what kind? Positive or negative? It's a negative, therefore I need to make sure that I slap that negative sign on at the end. So we solved it. X equals negative 9. Now what do you think? I know number 3, that's tough, isn't it, when you do it the first time? But like with number 4 in our second one, I feel like that went a little bit better. And we were probably a little more fluid than what we were in the previous one. Well, it's just going to get better as we go along. So remember, this is tough stuff for you guys. Algebra 1 is learning it next chapter. And so remember, there are times we'll jump ahead a grade or two in the curriculum that we have, and that's by design. It's to challenge those brilliant minds that you guys have, and we don't want you to get complacent and think, oh, this is easy, I have everything mastered, I don't need to learn anything new. There's always going to be new things to learn in life, guys, and that's in every arena, not just in math. So always be willing to challenge yourself and to grow, because that's what makes you a better person and a sharper mind. Okay, so we have x equals negative 9. I need to plug it back into my original equation, though, and make sure that's a true statement. And we'll do this one a little differently. There are a couple ways of going about it. We'll be simpler with this one. So we have the square root of 10 plus x. What is x? We found that to be negative 9. Okay, so instead of writing 10 plus negative 9, I'm going to simplify it. The negative overrides the positive and just say 10 minus 9. Okay, that's all under a square root symbol. This is not. Plus 6 equals 7. Okay? And so what we're going to do is we're just going to simplify what's underneath the square root or the radicand. What is 10 minus 9? 10 minus 9 is 1. So the square root of 1 outside of that square root symbol or that radicand is plus 6 equals 7. Guys, what's the square root of 1? In other words, what product of 1 is there that when you multiply it by itself gives you the number 1? Well, that's 1. That's that easy one. We like that one. 1 times 1 is 1, and so we can just drop on that one the square root symbol and just add the number 1. And we're left with plus 6 equals 7. What's 1 plus 6? 1 plus 6 we know is 7. Does 7 equal 7? Woo! Not only did we do things right, but as well we know that is a possible solution to number 4, that x equals negative 9. Okay, Let's do one more. You guys have done excellently. So let's do just that. This is a little bit different. Now, if you remember, I told you in our last class period that when there's just a negative outside of the square root symbol, it's important to understand there's an imaginary 1 between, and we just don't write it because it's redundant, kind of like an exponent of 1. Well, it's understood, and it's a waste of time and space to write it. But the reason I wanted you to understand, well, there's actually a number and an imaginary one there is because sometimes you'll have numbers that not only are real, but also are not imaginary in that they're written explicitly right there in front of you. And that's true with the number 4. Negative 4 outside of, or what that means is, it's being multiplied to whatever term is found inside of that square root symbol. Guys, if that negative 4 is being multiplied to that square root of x, and I'm reversing order of operations here, and so I do multiplication before what's set off in things like parentheses, brackets, square roots, etc. If that negative 4 is being multiplied to the square root of x, what's the opposite operation of multiplication? It's division. And so to get rid of that negative 4, since it's being multiplied to the square root of x, I'm going to divide it by negative 4. And that's going to get rid of it on this side. But what I do to one side, I must make sure that I do to the other. And so what I have left is the square root of x equals, what's 28 divided by negative 4? Well, 28 divided by 4 is 7. And if you have one of two numbers that are negative when you're dividing or multiplying, that's always going to make you end up with a negative number. Now, I want you to consider something. We can go work all this out, okay, we will, but I'll show you why we didn't have to. Because if we end up with, or we have at any point, the square root of x and x alone that equals a negative number, what did we already determine is the answer in that situation? No solution. But let me show you why it's going to be that way once again. We have the square root of x, we need to solve for x. What's the opposite of the square root? The opposite process is to square it. And what you do to one side, you must do to the other. So I'm left only with x on the left side, and what's negative 7 squared? Or in other words, negative 7 times itself. That's not negative 7 times 2. It is negative 7 times negative 7. That's what being raised to the second power means. 7 times 7 is 49. And because you're multiplying two negative numbers, you're always going to end up with a positive number. That's why we drop the negative sign. Okay, so let's plug in what we found x to equal 49 into our original equation. What we have is negative 4 times, that's understood, isn't it? Negative 4 times, that's understood, the square root of x, which we have discovered to be 49, not a very good 4, but that's a 4. 49, okay, equals 28. Okay, first thing we need to do is simplify what's on the inside of the square root. What is negative 4 times? We're going to find out, but first, what is the square root of 49? In other words, what number times itself gets you to the original number of 49? And that is, as a product of 49, is 7. 7 times 7 is 49. And so what I'm going to do is now I can drop the square root sign because I'm simplifying it, but I will keep it in parentheses because remember that negative 4 is being multiplied to whatever is inside of that square root value. And so negative 4 times 7, because the square root of 49 is 7, or 7 times 7 equals 49, equals the number 28. Guys, what's negative 4 times 7? Negative 4 times 7 is negative 28. 7 times 4 is 28. One of the two is negative, so don't forget to keep your negative sign attached. Is this a true statement? Negative 28 equals positive 28. Is that accurate? No. Negative 28 does not, has not, will not, in fact, never will equal 28. And therefore the answer is no solution. That's why it's important to check these. But remember, we had a handy dandy shortcut that we learned from earlier from number 2, that if we ever come across the square root of x and x alone equaling a negative number like this, the square root of x equals negative 7, you can just stop right there, because the square root of a number is never going to be a negative. Because if you take a product of it and multiply it by itself, and originally it was positive, it has to be a positive number. If you have a negative number and you take it as a product times another negative number, what's a negative times a negative? Always equal. It always has to be a positive. And so if you have the square root of x and x alone equaling some negative number like negative 8 or negative 7, look, you're always going to end up at this place, so you might as well just stop right there at that point and say there's no solution to it. So that is our lesson on radical equations. I hope that makes some good sense. Again, I'll say I know it was a pretty good jump today, so I expect us to have some questions, and that's good. Please ask, fire away. Let me know any questions that you have. I'll do my best to answer every one of them that you do have. Again, if we need to, we can go through some one-on-one time together, whether through Facebook chat, email, or text or phone call, whatever's best on your and your family's end, and I'm glad to help you guys out any and every way that I can. Okay, well, we're going to quit there, and we'll pick up not next week, but tomorrow, building on some more things, but that's radical equations. And I trust that you guys are going to continue to do a good job with it. Thanks. Appreciate your time.